Welcome to Idiomatic. هذا السؤال is another example of the concept of viewing the motion of an object within accelerated frame of reference from either an inertial frame of reference or non-inertial frame of reference. If you want to know more about the concept of inertial and non-inertial frame of reference, you can check the video from the link above. For now, هذا السؤال. عندي pendulum جوات هيدي trolley which is moving with a constant acceleration a to the right. بما انه pendulum موجودة within accelerated frame اللي هي trolley، في اعمل view لهيدي الموشن from two different frame of reference. Either from the accelerated frame of reference or from the inertial frame of reference which is the ground. Now هيدي الباندولوم كانت على initial position، صارت على final position بعد ما هيدي الترولي مشيت بهيدي constant acceleration A. هيدا بيعني انه وصلت على هيدا الفاينل بوزيشن وصارت فيكست. فبالنسبة للأوبزيرفر، لو في عندي أوبزيرفر جوات هيدا الكارت عم يطلع دايما على هيدا الباندولوم من هيدا الفيكس بوزيشن. هيدا الباندولوم يعني ما عم تتحرك بالنسبة لهيدا الأوبزيرفر لأنه وصلت على هيدا الفاينل بوزيشن وصارت فيكست. Thus acceleration لهيدا الباندولوم بالنسبة للأوبزيرفر أو بالنسبة للأكسلريتد فريم أوف ريفرنس itself is zero. ليه؟ لأنه صارت فيكست. أما بالنسبة للأوبزيرفر is viewing the motion from an inertial frame of reference. صح هي صارت fixed، بس بالنسبة له هو كان initially هون مثلا عم يطلع على هيدي الباندولوم على هيدي الفاينل بوزيشن، وصارت finally بما انه عم تمشي الكارت وهي موجودة جوات الكارت ونفس الانجل ثيتا، بالنسبة له initially كانت هون وصارت finally هون، يعني صار في تغير بالبوزيشن دلتا اكس. بما انه الفيلوسيتي كمان عم تتغير بس variation of velocity is constant عشان لأنه acceleration is constant بهذا السؤال. okay. Thus هيدا الباندولوم بالنسبة للobserver standing from within an inertial frame of reference بالنسبة له is moving with a constant acceleration a اللي هي نفس acceleration للترولي. okay. أما بالنسبة للobserver is viewing the motion from within an accelerated frame of reference، هيدا الباندولوم بالنسبة له هي fixed and acceleration equal to zero. so هيدي هي الفكرة هون. We are viewing the motion of a pendulum within an accelerated trolley either from the accelerated frame of reference itself or from an inertial frame of reference. Okay, let's start. A trolley has a simple pendulum suspended from a frame fixed to its desk. The trolley is on horizontal rail and accelerates toward the right with a constant acceleration a equal to 1 meter per second square. The angle of inclination of the pendulum. عم يسأل عن angle theta. أول شيء مثل ما حكينا. Case 1 we are sending the motion from within an inertial frame of reference. Okay, first of all هيدي initial position وهيدي final position. عندي force tension والmg. This is positive y axis وهيدا positive directional x axis. بما انه هيدي هي الانجل ثيتا which is between the initial position and final position of the pendulum، يعني هيدي صارت الانجل ثيتا also. Now tension is projected along the y-axis and the x-axis. So Tx equal to T sine theta I and Ty equal to T cosine theta j. Okay, let's consider the motion along the x-axis. Since the cart is moving along the x-axis to the right with a constant acceleration a, then Ax equal to total A equal to 1 meter per second square I. So along the x-axis, summation of forces along the x-axis equal to MA, x equal to MA. We have T sine theta equal to MA. This is equation 1. Second equation along the y-axis, since no motion along the y-axis, summation of force y equal to 0. Then we have T cosine theta minus mg equal to 0. Then T cosine theta equal to mg. This is equation 2. Then we divide equation 1 by equation 2 and we get T with T will cancel, mass will cancel with mass. Then we get tangent theta equal to A over G. Thus theta equal to shift tangent A over G equal to shift tangent 1 over 10. Thus theta equal to 5.7.71 degree. Thus, the right answer is B. Now, review motion from another frame of reference, which is the accelerated trolley itself. Okay, so case 2, viewing the motion from accelerated or non-inertial frame of reference. Also عندنا initial position كانت الباندولوم هون، صارت على final position صارت هون. This is tension. We consider the axis of motion. This is the x-axis, this is theta, and this is theta, this is y-axis. Now بما إنه نحن عم ندرس motion of an object within accelerated frame of reference, we must consider the presence of a pseudo force F. F as a direction is opposite to the direction of the acceleration. As a magnitude, F equal to ma. So F بهذا direction and mg. So مثل ما قلنا بالنسبة للaccelerated frame of reference, the acceleration of the pendulum is 0 along the x-axis and y-axis. Then summation of force along the x-axis equal to 0 along the x-axis. Then we get plus t sine theta, because I consider the positive direction in this way, okay, minus a pseudo force equal to 0. Then we get t sine theta equal to ma. This is equation 1. Considering equation 2, y-axis, we have summation of forces along the y-axis equal to 0, and thus d cosine theta equal to mg. يعني حصلنا على نفس two equations as in the case 1. So divide 1 by 2, we get t cancel with t, mass cancel with 1. Then tangent theta is also equal to a over g. Thus theta equals tangent a over g. So in this question, we have studied the motion of a pendulum which is located within accelerated trolley, either from the accelerated frame of reference itself. In this case, we must consider the presence of a pseudo force, which is magnitude equal to mass of the pendulum multiplied by acceleration of the trolley, which is the accelerated frame, or we view the motion from an inertial frame of reference, where we look to the pendulum as a part of the trolley, which has the same constant acceleration a. And that's it. Stay safe.